Welcome to our best regression project. Now, here our client was a big property consultant who had operations in six major metro cities of India: Bangalore, Chennai, Delhi, Hyderabad, Kolkata, Mumbai. Now, if you see the data which was provided to us, then it had these features: area, location, number of bedrooms, resale, that is whether the property is for resale or not, whether the property has already maintenance staff, provision for maintenance staff, maybe a maintenance servants quarter or something, gymnasium, swimming pool is there or not, landscape garden is provided, jogging track, rainwater harvesting is present or not, indoor stadium, shopping mall, then maybe more features on this side, uh, intercom, sports facility, ATM, clubhouse, school is nearby or not, 24 by 7 security is provided, power backup generator is there or not, how many car parkings are there, staff quarter is there or not, cafeteria included in the campus of the property, multi-purpose room is there, so something like conference room or meeting room, hospital is nearby or not, whether the property is fully furnished and fully equipped with electronic equipments like washing machine, gas connection is there, AC is there or not, Wi-Fi is provided, whether there is children's play area in the campus, whether the lift is available or not, whether the bed is available or not, Vastu compliant or not. Now this Vastu compliant is an interesting thing, and that shows the importance of working with real life data, because most of the time when interns come to us for a job or internship request and we ask that what have you done so far, they normally give that famous Boston data sets. Nowadays that Boston data set has been removed because some ethical issues have been detected in that, but that's a different thing. The point is that you are going to work as a data scientist in India, and why don't you work with this particular Indian? Why don't you work with a data set which is relevant in Indian context? So this Vastu is not much of a factor in many of the foreign countries, but in India it is a major factor, and many people buyers are there which do not buy the property just because it is not Vastu compliant. Okay, microwave is there or not, golf course, TV, dining table, sofa is there or not. So many features are there. Then maybe still more, I think, yeah, wardrobe is provided or not, and refrigerator is there or not. So you can see that there are so many features. Except this price, which is the response variable, all these are feature variables. And this is the data set for Bangalore, but Chennai also had all same features. Delhi also had all same features, and Hyderabad also had all same features. Bangalore had roughly 6,200 observations. Chennai had roughly 5,000 observations. So the number of records available for different cities was different, but the features are same. And the desire of the client is that he wants to develop a prediction model which can build, which can predict the price of the property based on these features. Okay, so this is the business case. Now, what made this an interesting project that I am telling you? One is that all cities have same feature. So initially, a data scientist would be tempted to build a model, which single model which works for all six cities, but it did not work that way. There is a reason for that. Second thing is that in this location variable had so many categories. Total, if you consider all six cities, then this location is having around more than 800 categories. So even after doing maybe label encoding or other encoding techniques, there would be so large number of columns that it would be practically not good model. I mean, it's not possible to build a good model out of that. And at the same time, if you leave the location, then it was found that the model's various metrics, accuracy and F1 score, etc., they R square, in regression R square is often decided as a important metric. Then they are not at all satisfactory. So on one side we wanted to keep the location, and on the other side we want to make the model simplified. That is one reason. Second reason is that we decided that okay, whether to make one model for one city or multiple models, then that is one model for all the cities or one model for each city, that is six different models. Okay, now here we performed ANOVA test and checked whether this choice of the city makes a difference in the price predicted. Okay, ANOVA clearly gave the indication that choice of city does affect the price predicted when everything else is same. So that means that much was confirmed that we will build six different models. That would make the user interface also easy, because in the user interface, even if you provide a drop down menu, that drop down menu with 860 or 870 locations, if we build a single model for all cities, that would be very unwieldy. Okay, so we have to divide it, and when you divide city wise, then each city had around maybe 100 locations, 120 locations, which was manageable. I will show you the user interface, and you will feel that it is worth doing this splitting city-wise. But initial data pre-processing was done by combining the data frame. We were given six different data frames, so we combined that data frame. So here is the some work which was done by Jupyter Notebook. For example, some manual exploratory data analysis was done, and it was found in these last five rows that some variables, say children play area, is there or not. Now it should be 0 or 1, because it was already binary encoded in the given data set. But here some rows were found which were having 9. See, AC is there or not? Again 0, 1, but 9 was there. So obviously these rows had to be removed, and these rows were also duplicated. So we needed to uh, do a lot of data cleaning. Okay, then we removed these rows which had 9 values. Then thereafter we found the type of data. All the columns had object data type, but machine learning models require a numeric data type. So we had to convert this object into numbers. But before that, here I have written one note, because this is the way in which we work at our consultancy, that we use automated tools also, but we do not leave the uh, manual process completely. So kind of double check is there, and nowadays there are so many automated exploratory data analysis library. Here are examples: detail and panda profiling, which is now called y data profiling, SweetWiz, AutoWiz, data prep, Klib, DABL, SpeedML, EDAVs, Detail, and so on. Now we did use a few of these. Detail I used as far as I remember, and AutoWiz I was using, Y data profiling was used, and SweetWiz was also used. And its a separate report was prepared and we sat with client with that report and explain why the um, project is complicated and therefore why the fees being charged is a little bit on a higher side, and why this division of making this kind of user interface in which there are six different pages for each city. Okay, then let us do some data pre-processing. So these are the columns which we wanted to convert into numeric columns. So we converted them into numeric column. First we combine all data sets and made one master data frame. So here this is now for master data frame. All six were stacked one above another. Then master data frame had all cities, and then we cleaned it. Some rows which were having that 9 and everything duplication. So there were 32,963 rows to begin with, but ultimately after cleaning, it was found that actually there are only 10,093 rows. Okay, and remember that is in master data frame. So that is combined number of rows for all the cities came out to be only 10,000, and that was one cleaning required. Then one hot encoding to convert all numerical, categorical variables into numerical. Then we also found how many unique categories are there. Then we found that here location you can see 849 unique category, area 1605. As such, area is easily converted into number, so its category does not matter. Similarly, price, here it is the categorical variable, but we can just convert it into a number. But regarding location, you can see the location is like this kind of maybe Khar Nagar and all that, or here you can see in the topmost data, yeah, JP Nagar and all that. So it has to be label encoded, or maybe some other target encoding or other that kind of technique has to be used. But these required to be converted into numbers, and finally all others were I think already converted by one hot encoding. So here label encoder, use the label encoder. I'm not going into all this because this is not a data science class. This is just a kind of explanation of how model is built and what we do as a data scientist. And maybe this is also this much explanation is also provided just to ensure some future or prospective client that we do our work thoroughly. Okay. Then these city and location columns were initially tried to drop. Okay, we tried to drop, but it was found that model accuracy was not sufficient. So we decided that let us perform ANOVA. ANOVA came out to be for CT 1.23 into 10 raised to minus 9. So that is very small p value, and that means that it is clear that CT makes significant difference, and therefore we cannot drop CT. But unfortunately for location, ANOVA failed. It gave NAM. Now it did not give any conclusive proof. Okay, so we performed another test. It is a parametric test called Kruskal-Wallis test, and after that we found that even CT, even for location, it was earlier found that location was not significant. CT was significant, but location was not significant. So we were tempted to drop the location column, but remember, this whole analysis is being done for master data frame, that is combined data frame for all six cities. Now, we easily we can understand the effect of city by again dividing it city wise, splitting the data set vertically into different cities. But about location, Though it was found that location does not matter and could be dropped, when we tried to drop and the model accuracy suddenly plummeted. It was around 60%. Now property prices are in crores in these metro cities. So if there is 40% error in maybe a 5 crore property, that is too big an error to be acceptable. So we decided that let's keep the location at present, and we will perform the same test, Kruskal-Wallis test, once again for individual city-wise data frame. And it was found true significance of location column was found when we took the data of single city, and then same test were performed, then it was found that location is also significant for a given city. Location is significant, so then we decided to keep it, and that suddenly caused a big jump in the accuracy level and R square. From around 64 R square, 64%, we directly went above 90% or 93% R square. You can imagine the jump. So often the data treatment and how we apply statistical hypothesis, how we form the hypothesis, which columns to keep, which columns to re-engineer. These things are more important than choosing the algorithm. In fact, choosing the algorithm can now be even done by automated libraries, and it will find the best possible algorithm for your data. But the question is, your data means you have to feed your algorithm the best possible format of the data. Which so this is the scope for creativity, and here the AI or other things may not replace the data scientist for still long time. Now, then we continued with our in city-wise six data frames. They were saved city-wise, and we were using encoding. Bangalore was 0, and here this was the city encoding 0, 1, 2, 3, 4, 5. Okay, for various cities. So we saved a city-wise data frame, and in further analysis we used them. Okay, now again there was some chance of deduplication. So we did the deduplication, and we also found maybe there are some columns which are single valued, and this single valued column in different cities were different. For example, in Delhi, Wi-Fi was single valued column. So from Delhi data frame, Wi-Fi was dropped. Golf course was single valued, it was dropped. Wardrobe was single valued, it was dropped. But in Chennai, Wi-Fi, golf course, wardrobe, okay, they are the same. But in Mumbai, only Wi-Fi and wardrobe were dropped. So in short, after dropping these columns, what happened is that now the number of features in different cities are different. Now you can understand the complexity which this will bring. That means that when we make the user interface, then the features or the desired characteristics of the property which will be displayed on the user interface, they will be different. Further complication was created by this. We tried to find which features are correlated with the target variable for each individual city. So such heat maps were generated, and correlation with price for Delhi, it was found this. Then Chennai, correlation of price with different features for Chennai, etc. And of course, correlation is not causation, so we did a further check by variable importance plot. So variable importance plot were generated. It is yeah, here. This is variable importance plot for Delhi, variable importance plot for Chennai, this variable importance plot for Mumbai, and so on. This again introduced some complexity. Obviously, we cannot take all these features uh, in our model, because that will make our model very complex. Such models will overfit and it will not be generalizable. So we have to, and even computational resources wise, it is not good practice to take so many features. So we take top 20 features, but you can see top 20 of these and top 20 of next city will not be same. Here, for example, area resell location encoded indoor games. Here, area jogging track, cafeteria, rainwater harvesting. So here something, then dining table, refrigerator, jogging track, bedrooms. So in short, the variables which are top 20 variables for different cities are different. This again means that from the analysis of data itself, it was clear that six different models will be required. That is okay, but six different user interfaces will be also required, on which we will display only these top 20 features. So this shows the importance of the teamwork between the data scientist and the front end developer who is developing the UI, that is mainly working in HTML and CSS. Okay. Now this variable importance plot were plotted. Then next is top 20 features were found, and we decided that we will keep only six data frames for each city with only top 20 features. Here you can see those top 20 features for Delhi. Price, area, resell, location encoded. Here price, area, jogging track, cafeteria, rainwater. Here price, dining table, refrigerator. So many of the features were different for different cities. We saved these six data frames uh, and only with top 20 features, cleaned and with top 20 features. Then we continued further, and thereafter this is Mumbai data frame top 20. This is Delhi data frame top 20. Then one important thing it was found is that the data sets were highly imbalanced. So we did oversampling, and we uh, brought balance to the data set. Random oversampling was used because random oversampling closely matches with the way in which the app is going to be used. When the app is actually going to be used in the field, then various users will click his chosen city and then his chosen area and put different values for the features. How many bedrooms he desires, how many square foot area does he desire. So obviously those users who are going to use the app in practice, they are going to come from any different locations in any different city of out of these six metro cities. So that means there is no pattern in those user, that everybody will come from same area of Bangalore or everybody will desire five bedroom house only. There is no pattern. So that's why random oversampling worked excellently. And after balancing, modeling was done, and for each data frame we created the models and saved the models. These are the models somewhere here, pickle models and joblib models. Both were saved, except any one is required. So best XGB, it was found XGB, extreme gradient boosting was the best. So best XGB for Bangalore, best XGB for Chennai, Delhi, Hyderabad, and so on. Now from here we go to PyCharm, and I show you the actual way in which the app is used. Okay, so uh, our PyCharm is here. You can see these are those best models, and these are some images which we used on the user interface to make things a little bit attractive. These are the various applications, various Python files. So Chennai detailed.py, Bangalore detailed.py, Hyderabad. So we created different files, and location mapping was done by using dictionary, and so on. Okay, so this is how things are done. Now this is the basic app, and let me run it, because our main purpose, as I said, I have already taken 25 minutes. But unless such idea is given about what was the business problem, what kind of data was it, you will not get the clarity why this kind of user interface was made. Okay, so let me run the app. App is running on this port, and I click here. This is welcome to housing price protection. First, the user selects his city. Let us say he selects Bangalore. Now he enters what area does he require. Maybe say 3,000 square foot. How many bedrooms are required? Maybe three. Which location in Bangalore? I am just writing randomly, say electronics city. Then school is nearby or not? I will say yes. Rainwater harvesting in Bangalore is must. Staff quarter, say no. Intercom, yes. Cafeteria, yes. Lift is available or not? Yes. This is also one important reason why localized data sets are useful. In many of the developed countries, this feature may not be there at all, lift available, because it is taken for granted that if there is a building, lift will be there. But in India, still there are buildings where lift is not there. So this has to be provided as a feature. Yes, I want lift. Then maintenance staff maybe no. Gas connection, yes. Landscape garden, obviously yes. Vastu, no. Or yes, let us say I am Vastu believer. Hospital nearby is absolutely necessary. ATM, yes. Digital economy, now we are. And indoor games, yes. For kids, it is required. Washing machine, I don't need. I will purchase myself. Car parking is absolutely mandatory. Shopping mall nearby, mandatory. Golf course, I don't want. Predict the property price, and you can see that the property price is around 2 crore 10 lakh 89,720. This is based on around 2022 data maybe. So I don't know whether property in Bangalore is available or not. And you can see, as soon as predict property price is placed and price is displayed, all this have again uh, what you say reset. So when it is ready for next area or next location. Okay, now I will go back to the city selection. You can go to other city, maybe Mumbai. You can see here the features are different: dining table and staff quarter and gymnasium. While if I go to again Bangalore, then you will see that school nearby and rainwater, etc. They are the different cities. Now I'm not showing it for Mumbai because it is one and the same thing. But now you can understand this location drop down is very long. That also, after we divided into six pages for each city. Okay, so our app had this. If you see this index file or templates, then there were maybe where it is static templates here. Yeah, Bangalore HTML, Chennai HTML, Delhi HTML, Hyderabad index, that is the landing page, and Kolkata and Mumbai. So that's how it is. And this app was making it was also a very nice experience, and the client also was pretty happy. And still today we use this app to train our interns for data scientists. Of course, for production, still more bells and whistles need to be added, and much more unit testing and various kinds of testing is required. And ultimately, you have to deploy it on cloud. Thank you.